Good afternoon. Today we're going to discuss the nature of the roots of quadratic equations. So before we identify the nature of the roots of quadratic equations, let's first set the objective of today's lesson. So at the end of the lesson, you should be able to describe the roots of a quadratic equation using the discriminant. Last time, we discussed the process of deriving the quadratic formula, and you are aware of the quadratic formula already. And the formula is, of course, negative b. X is equal to negative b plus minus square root of b squared minus 4ac all over 2a. Okay, you can see it on the screen. This is the quadratic formula. Now, since we are looking for the nature of the roots of quadratic equations, uh, the only expression that we will be using is the discriminant. And where can you find the discriminant? It's actually the expression inside the square root symbol, okay, that is b squared minus 4ac. So we label the discriminant as d. So here we have d, and that is equal to b squared minus 4ac. We will be needing this discriminant in order for us to identify or to determine the nature of the roots of the quadratic equation. So if you solve the value of d, and this will be the result, then there's a corresponding nature of the roots of the quadratic equation. So I created here a table for the nature of the roots of quadratic equations. So in the first column, you have the value of the discriminant. And when we have the discriminant as a number greater than 0, and if it's a perfect square, okay, the corresponding nature of the roots is there are two real rational roots of the quadratic equation. Okay, and next, if your d or the discriminant is greater than 0 and it's not a perfect square, there are two real and irrational roots. When your discriminant is equal to 0, there are two real and the roots are equal. Okay, that is when your discriminant is equal to 0. Now, when your discriminant is less than 0, there are two imaginary unequal roots. Okay, so let's have some examples. So let's determine whether the discriminant of this quadratic equation is greater than 0, equal to 0, or less than 0. So we have here the quadratic equation x squared minus x minus 6 is equal to 0. So the first thing that we need to do is to identify first your a, b, and c of this quadratic equation. And of course, please remember that when the quadratic equation it's not written on its standard form, there's a need for you to write the quadratic equation in its standard form. So here, your a is equal to 1, your b is equal to negative 1, and your c is negative 6. Okay, applying the formula, the discriminant of a quadratic equation is d, and that's equal to b squared minus 4ac. Then after that, we need to substitute the values of a, b, and c to the formula. So we have here your negative 1 raised to the second power minus 4 times 1 times the value of c, that's negative 6. And here you have 1, that's negative 1 raised to the second power, that is 1. And you have negative 4 times negative 6, that is positive 24. And the resulting number is 25. That's the discriminant. And you notice that your answer is a perfect square. So here, your discriminant is greater than 0, and it's a perfect square because you can extract the square root of 25. Okay? So we determine the nature, therefore, of this quadratic equation, the nature of the roots, rather, of this quadratic equation. So since it's the discriminant is greater than 0 and it's a perfect square, we have here as the nature of its roots. So there are two real and rational roots. Okay? So there are two real and rational roots. Okay, next we consider this quadratic equation. So let's identify the nature of the roots of this quadratic equation. So we have here x squared minus 6x minus 2 is equal to 0. Again, let's identify first the value of a. So a here is 1, your b here is negative 6, and your c is negative 2. Okay? And again, we need the formula for the discriminant, and that's equal to b squared minus 4ac. We substitute the value. You have negative 6 raised to the second power minus 4 times 1 times negative 2. So negative 6 raised to the second power is actually 36. Okay? It's positive 36. And you have negative 4 times negative 2, that is positive 8. And that's positive 8. Sorry. Okay, it's positive 8. Okay, and 36 plus 8 is actually 44. Okay, and if you notice, you cannot extract the square root of 44. So it falls under the second condition. Okay, what's the second condition again? When your d is greater than 0 and it's a perfect square, there are two real and irrational roots. So the roots, therefore, here of these quadratic equations are two roots that are irrational. Two real and irrational roots. Why? Because your 44 is not a perfect square. Okay, but it's still greater than 0. Now, let's proceed to the third example. That is the equation x squared plus 6x plus 9 is equal to 0. Again, we identify the values of a, b, and c here. So your a here is 1, your b is positive 6, and your c is positive 9. And again, applying the formula, you have here d, and it's equal to b squared minus 4ac. Now, there's a need for you to substitute the values. So you have your 6 raised to the second power, because the value of b is 6 minus 4 times 1 times 9. Then, again, simplify this. You have 36 minus 36. And you notice that your d here is 0, because 36 minus 36 is 0. And the nature of the roots of this quadratic equation is actually when d is 0, there are two real and equal roots. Okay, there are two real and equal roots. Okay, because the discriminant again is, in this particular example, is 0. Now, let's proceed to the fourth example. You have here x squared plus x plus 5 is equal to 0. Let's test whether the discriminant is greater than 0, equal to 0, or less than 0. Again, the first step, we need to identify the values of a, b, and c. So a here is 1, your b is 1, and your c is 5. Then you have the formula for the discriminant, that is d, and that is b squared minus 4ac. Again, substituting the value, you have 1 squared minus 4 times 1 times 5. And of course, you have 1 minus 20, and it's negative 19. Okay, the value is negative 19 because 1 minus 20 is negative 19. And in this particular example, your discriminant is less than 0. Therefore, the nature of the roots of the quadratic equation is actually two imaginary, okay, two unequal and imaginary roots. Let's look at the definition there. Okay, your discriminant is two unequal imaginary roots. Okay, so the thing here is you need to know the formula for the discriminant. You need to identify the value of the discriminant, and then you decide on the nature. Anyway, it's given on the table. Okay, so the corresponding nature of the roots of the quadratic equation is dependent on the value of the discriminant. Now, let's look at this, no? The sum and product of roots of a quadratic equation. So there are some instances wherein you are required to find the original quadratic equation given the roots, and we can apply the formula that we will be discussing afterwards in finding the original quadratic equation. Okay, so consider this one. The standard form of quadratic equation is ax squared plus bx plus c is equal to 0. Then we divide both sides or all the terms of the quadratic equation by a. Hence, you have x squared plus b all over a x plus c all over a, and that is equal to 0. Now, we're going to form an equation. Okay, we're going to have a formula for the quadratic equation, that is by using the roots r sub 1 and r sub 2. So given r sub 1 and r sub 2 as roots of the quadratic equation, your r sub 1 plus r sub 2 is equal to negative b all over a. Okay, you can see it here. And your r sub 1 plus r sub 1 times r sub 2 is equal to c all over a. And the quadratic equation is formed by simply applying the formula x squared minus the quantity of r sub 1 plus r sub 2 times x plus the product r sub 1 times r sub 2, and that's equal to 0. Okay, let's consider this one, no? So let me erase this part first so that I can explain very well the formula. Okay, so we will going to use two methods here. Okay, we're going to use two methods here. So the question is, what is the quadratic equation, the original quadratic equation with roots -5 and +1? And if you notice on the screen, we have here method 1. So I actually named our original method with this word or this title, method 1. Okay, so what is that method 1? The original thing or the usual thing that we are doing is, of course, we form the factors out of the given roots. So we have here x plus 5 and x minus 1. Then we multiply. Okay, so you have here x squared plus 5x, and you have negative x, and negative 1 times 5 is negative 5. Then you add. So x squared plus 4x minus 5. Okay? So therefore, the quadratic equation containing or having the roots -5 and wait, I will just erase this part. -5 and +1. Okay, -5 and +1 is the quadratic equation x squared plus 4x minus 5, and that's equal to 0. So this is your quadratic equation. Okay, we proceed to the second method. Okay, And in this method, we will be using the formula. So this is method 2. So the formula is, let me write the formula. That is x squared minus the quantity of r sub 1 plus r sub 2 x plus the product r sub 1 times r sub 2, and this is equal to 0. Okay, so since your r sub 1 is equal to negative 5 and your r sub 2 is equal to 1, you can say that, or you can actually make use of those values to get the original quadratic equation. And after that, we're going to compare. Okay, let's compare whether we will get the same answer as our first method. So here, we just substitute the values of r sub 1 and r sub 2. So x squared is equal to, or minus rather, that's negative 5 plus 1. You have x there plus, of course, the product of r sub 1 and r sub 2. Negative 5 times 1, and this is equal to 0. So simplifying further, we have x squared minus the quantity of negative 4x minus 5, because negative 5 times 1 is negative 5, and this is definitely equal to 0. So you have x squared plus 4x minus 5, and this is equal to 0. And if you notice, our answer is the same with our first method. Okay, the same with our first method. Now we will have another example. Okay, we will have another example. So for example, you have here your first root. Let me erase this part. Okay, as 1, r sub 1 is 1 minus square root of 2, and your r sub 2 is 1 plus square root of 2. Okay, let me erase the solution first so that I can show you how it's being done. Okay. Okay, so we go back to the problem. So the given roots are r sub 1, and the value is 1 minus square root of 2, and r sub 2, that's equal to 1 plus square root of 2. Okay, so you have here the formula x squared minus r sub 1 plus r sub 2 times x plus r sub 1 r sub 2, and this is equal to 0. Then we substitute x squared minus 1 minus square root of 2, that's the value of r sub 1, plus 1 plus square root of 2, that's the value of r sub 2, times x plus the product 1 minus square root of 2 times 1 plus square root of 2, and this is equal to 0. Okay, and if you notice here in our equation, you can cancel out terms. So you can cancel out your square root of 2 and your negative square root of 2 and your positive square root of 2. So we simplify the equation. So we have here x squared, okay, minus 1 plus 1 is 2. So 2 times x plus, of course, the product. And this is a special product, no? If you can still remember, if you are multiplying a minus b by a plus b, the result is a squared minus b squared. So therefore, if we are multiplying 1 minus square root of 2 by 1 plus square root of 2, we have 1 squared minus square root of 2 squared. So simplifying further, we have 1, okay, 1 minus 2, and this is negative 1. So that if we are asked to simplify 1 minus square root of 2 times 1 plus square root of 2, the answer is negative 1. Okay, and this is equal to This is equal to 0. Simplifying further, we have x squared minus x minus 1 is equal to minus 2x rather. This should be 2x. Minus 2x minus 1 is equal to 0. Okay? So that ends our discussion. I hope you learned something today. Goodbye.